Hello, I am your personal tutor, Mr. Samuel Enyima, and I welcome you to the Phases for the High School Virtual Classroom. Today, we are continuing the lesson we started on kinematics, and this is the lesson number 2. Earlier, you got introduced to kinematics where you looked at some motion types and their examples. Today, we want to center the lesson on terminologies of motion of a body. And the learning outcome is, by the end of this lesson, all learners and scholars will be able to define some basic terms as used in motion of a body. We'll also learn the comparison and contraction between distance and displacement as parameters of motion. We also look at the comparison and contraction between speed and velocity as parameters of motion. Then take some qualifiers of some terms used in motion. So this will be the learning outline for the day. Let's start with the first one on some basic terms used in motion. And I must say, these are the terms which are referred to as the parameters of motion. I urge and entreat all learners to take it very serious, understand it, learn it so that you'll be able to define it whenever you are called upon to explain to someone or to enhance your own understanding. And we will look at these terms. The first is distance, second, displacement, third, velocity. And with velocity, there are some qualifiers like instantaneous velocity, uniform velocity, non-uniform velocity, and of course, average velocity. The fourth is acceleration. With acceleration too, you will have other qualifiers like instantaneous acceleration, uniform acceleration, non-uniform acceleration, average acceleration. And lastly, deceleration, also referred to as retardation. And these terms are really called parameters of motion. You cannot describe motion without these terms because deep rooted in this are the position, the velocity, and the acceleration that describes motion in totality. So let's start from the first one, which is distance. Friends, distance is simply the measure of the magnitude of the path traveled by a body. I will explain into detail in about 2 or 3 slides from now. You can also say distance is the total sum of the complete path covered by a body in motion. That is, if you were at point A and you walked to point B and proceeded to point C, to look at your total distance, it could be said that you have covered AB as a distance or as a magnitude of the path plus BC. So the total complete path that one has covered, a body in motion has covered, is referred to as distance. And the SI unit of distance is meters. That is something brief for distance. The second term that you need to know is displacement. And just as you can get the word placement from it. Then the negative is this, meaning if a body is placed in one position and the position is changed to another different position, you can say the body which was initially placed has been displaced. So displacement simply means the shortest distance between an initial position and the final position of a body. So that distance, the magnitude of the path between where a body was initially and now where it is finally, is referred to as the displacement. Technically, you could define it as the measure of the distance traveled by a body in a specified direction. And so, what makes displacement different from distance is displacement, unlike distance, has a specific direction. Okay. Now, the SI unit of displacement is also meter, just as we have for the distance. So that is just for distance and displacement. Let's compare and contrast distance and displacement. But before then, let's try to understand the two of them in a particular context. So kindly follow with this illustration. This is your initial position or your home. And let's take this to be your school. Great. Now, there are many routes that you have to take in order to move from your home to your school. And the various routes are labeled in points like A, B, C, D, and E. And so your initial position is A, your home, and your final position is your school. Okay. Now, if one has to walk from his initial position, your home, to your school, or even go by a car, you travel this distance. So follow the distance being traveled. These are the routes you have to pass through in order to arrive at your final position. And the route taken is referred to as distance. So you say you have covered all these distance, A to B, B to C, C then to E, D, then D to E. And that is distance. And distance, as explained as the total sum of the path covered by a body. Mathematically, we could then say that then the distance in this scenario is the addition of the length or the separation of the points from A to B, as the distance, or let's say length A to B, plus BC plus CD plus DE. That is the distance. On the other hand, displacement, just look at where you were originally, A, as your initial position, and now where you are as a destination, your school, the final position. So just look at a straight line from your initial position to your final position in that particular direction without following the route that took you to your final position. So remember, we said the shortest distance or the shortest route to cover a particular path is the displacement. And we also said is the distance traveled by a body in a specified direction. And so displacement is more like a vector. It's just the vector A, E. So the distance from A to E. I believe this scenario has enhanced your understanding on what distance is and what displacement also is. With this understanding, let's contrast distance and displacement. And to contrast it means that we're looking for the difference, that sharp difference between distance and that of displacement. So, the first difference between distance and displacement is this. For distance, it is the total sum of the complete path traveled by a body in motion in a certain interval of time. Meaning, the path taken must all be summed up in order to get the total distance traveled. Whereas, for displacement, it is just the shortest distance, that separation between the initial position and the final position of a body, without looking at the various routes that the person has to go through. The second definition is, for distance, the motion of the body has no specific and has no unique designated path. You could take any other path to it, even though there is an initial point and a final point. You could go through so many routes to get to your destination. But for displacement, it is said that the motion of the body is given a specified direction and a designated path, straight. That straight path between the initial position and the final position is displacement. The third difference is distance is said to be a scalar quantity. And what that simply means is it is a quantity that has only magnitude, a quantity that you can express it numerically, but it has no direction. Whereas displacement is said to be a vector quantity, which simply means that quantity has both magnitude and direction. You can give it a quantifiable number, a numerical value, and as well assign a direction to it. The last difference is, you see, when you are given 2 points from an initial position to a final position, the distance between those 2 points could be the same if the path is uniquely designated. The same distance could be different if different paths could be chosen to arrive at the final destination from the initial. Whereas for the displacement, the direction, the distance, the separation, the magnitude between the 2 points is always the same. That straight, short path. So that is the differences between distance and displacement. Let's also compare distance with displacement. And by comparison, we mean similarities that exist between distance and displacement. So, 1, both distance and displacement have the same SI unit as meter. And in dimensional analysis, they also have the same dimension as capital L in a square bracket. If you took the earlier lesson on dimensional analysis, you will understand what this means. 2. Both distance and displacement have the same initial starting point and the final termination point. What this means is, from our earlier scenario created, the distance was A as a starting point, then its ending point was E. The displacement also had the A to be its starting point and the E to be its final point. So both distance and displacement in this case will have the same starting initial point and a termination final point. Then lastly, both distance and displacement of the motion of a body has the same magnitude on the condition that if the body moves in a straight line in a single direction. What this means is, if the path aren't crooked, but it is A to B and it's a straight line, then in this case, distance is from A to B on that straight line, and displacement is also from A to B on that same straight line. And in this case, both magnitude of the distance and the displacement are said to be the same. So this is comparison and a contraction between distance and displacement as parameters and terms of motion. Let's take the next term, that is speed. Speed as a parameter of motion is defined as the distance traveled by a body per unit time. Thus, the distance traveled over the time taken. Technically, you could also define speed as how fast the body moves, irrespective or regardless of the direction. So let's use this illustration to enhance our understanding deeper. But note that quantitatively, mathematically, speed is said to be equal to distance traveled over time taken. And the SI unit of speed is meters per second. So note this very well. Now let me explain speed for you in this scenario. You have two vehicles and each of them is supposed to cover a distance of 90 kilometers. It means they are all starting from a common point and they terminate and end at the same point. They're traveling to the same destination from the same starting point. And so the distance is phased as 90 kilometers. What this means is 90,000 meters. Now, let's compare the time of arrival and the speed here. With the first car, it traveled very fast and arrived 2 hours after taking off from a station. Now, we said speed is equal to the distance traveled over the time taken. That will mean the distance traveled as 90 kilometers over the time 2 hours. We will get the speed of 45 meters or kilometers per hour. That is for the first car. The second car seemed to be slowing down a little from the same point and end at the same destination, but it took this car 3 hours to cover the same distance of 90 kilometers. And so to compute its speed, we say 90 kilometers over the time 3 hours. And that will be 30 kilometers per hour. Between these two cars, if I should ask, which of them was moving faster? Is it the first car or the second car? And obviously, you will say it is the first car because it has a speed of 45 kilometers per hour as against the second 30 kilometers per hour. So still the same distance, but the time does the difference. The time of arrival makes it different. Means the car A was speeding more than car B. That is why we say speed is a measure of how fast a body moves, regardless of the direction. And it's also the distance traveled by a body per unit time. So that is the understanding of speed. Let's talk about velocity. On the other hand, velocity is the rate of change of a body's displacement or a body's distance in a specified direction with time. And velocity could be said to be the rate of change of a body's position in a specific direction with respect to time. That means when you compare the displacement of a body with time, it is velocity. Just as when you compare the distance of a body covered with time, that is speed. So note the difference here. So in terms of mathematical equation or expressions, you can say that velocity is equal to displacement over time taken. And the SI unit of velocity is meter per second, the same as that of speed. With speed and velocity, let's contrast these two based on the understanding you have gotten so far. And by contrasting, we are looking at the differences between speed and velocity. So now the differences for speed. It measures how fast a body is moving, irrespective and regardless of the direction. So speed only looks at the fastness of the body, but it does not deal with direction. For us, velocity measures the rate at which a body changes its position and direction. So velocity looks at how fast the body is moving and in what direction. The second differences dwells on the first and says that therefore you can say speed is velocity but without direction. And what this means is speed simply means yes, the body is changing its position with time, but we are not looking at the direction. Velocity, on the other hand, is said to be speed with direction. What this means is velocity is simply how fast a body is moving and in what direction is it moving. The third difference is for speed is the rate of change of distance with time. So mathematically, it is expressed as distance traveled over time taken. Whereas velocity only is expressed as displacement over time. So the rate of change of displacement with time. The next differences is speed is a scalar quantity, meaning it has a magnitude It can be given a quantifiable numerical value. You can assign a value to it as, say, 30 meters per second, but it has no direction. But for velocity, it is a vector quantity, meaning it has a magnitude and has a direction. So you can say it's moving 30 meters per second towards the west. It is moving 10 meters per second towards the south. So there is a specified direction. And lastly, the speed of a body cannot be zero, neither can it be negative. But for velocity, it can be zero, it can be negative, and it can be positive. What this means is distance cannot be negative once you're expressing it over time. But when the body is not changing its position, remember, velocity is displacement over time, and displacement simply means change of position. And so if a body does not change its position, it is at where it is, and so its displacement is zero. So these are the differences between speed and velocity. Still on speed and velocity, let's compare them by simply looking at similarities between the two. One, both speed and velocity have the same SI unit as meter per second, and they both have the same dimension as LT exponent -1 in a square bracket. 2, both speed and velocity offer a description as to how fast a body is moving, or as to why a body in motion is moving. So both speed describes the fastness of a body in motion. And the last is both speed and velocity represent a means to measure the change in position of a body with respect to time. So both look at position changing with respect to time. So that is the two for you. So far, we have looked at distance, displacement, speed, and velocity. Let's continue with acceleration as a basic term and a parameter of motion. And acceleration is defined as the rate of change of a body's velocity with respect to time. So notice this. When distance change with time, it is speed. When displacement changes with time, it is velocity. And when the velocity changes with time, it is acceleration. That is why this definition is written for you. You can also define acceleration as the measure of the rate at which the velocity of a body is increasing. So when you have velocity initially and it increases to a final point within a space of time, you can say the body is accelerating because there is an increase in the velocity. Mathematically, acceleration is therefore expressed as changing velocity divided by time taken. And the changing velocity simply means there is an initial velocity compared to a final velocity. So it is written as A equals V minus U over T, where this U represents the initial velocity, the starting velocity, the V, the final velocity, and T, time taken. So kindly note this formula. It is very, very important as far as motion is concerned. The SI unit of acceleration is therefore expressed as meter per second square. Meter per second square. So don't confuse this with velocity and speed, which were meter per second. This is meter per second square, and that is acceleration for you. Then lastly, on the terms, we'll look at deceleration. The name should ring a bell. Acceleration, deceleration. So that means an opposite of acceleration. So deceleration is also defined as the measure of the rate at which the velocity of a body is decreasing. So when the final velocity compared to the initial velocity is decreasing, that means that as the initial moves to final, you record a decrease in the velocity, then that is a deceleration. And this deceleration is also defined as the decrease in velocity of a body per unit time. We can also say the rate at which a body slows down. Simply, deceleration is a negative acceleration. It is a decreasing acceleration as well. However, mathematically, deceleration is also expressed as the acceleration, the change in velocity over time taken, and has a equals v minus u over t. Only that this time, when you find the acceleration, it will be negative. And whenever an acceleration is negative, it is called deceleration. But for the SI unit, it is also meter per second square as that of the acceleration. Friends, these are the various terms for you. Let's look at the last aspect where some of these terms have qualifiers. They have gotten other terms in front of them to enhance their meaning or to modify their meaning. And I call that qualifiers of motion. Some of the qualifiers are instantaneous, average, uniform, non-uniform. So let's look at this for only two. I'm going to compare just two of the terms, velocity and acceleration. So you can say instantaneous velocity and instantaneous acceleration. Now with the velocity, I know that it is the change of displacement with time. But technically, it's defined as the velocity of a body at an instant or precise moment or a short period of time. Have you understood that? That when you observe a body's velocity for a short period, for a certain instance of time, that is what we refer to as instantaneous velocity. Meaning, as I move from velocity A, initial velocity A, B, C, and D, I can just look at the velocity of the body between, say, B and C, not the total velocity, but at a certain point. That's what we refer to as instantaneous. That is, you can say, the rate of change of displacement of a body in motion with respect to a short period of time. Now, with the acceleration, the instantaneous acceleration becomes the acceleration of a body in motion at an instance, at a precise moment, or as a short period of time. Acceleration, we know, is change of velocity with time. And so you can say the rate of change of velocity of a body in motion at a short period of time. So instantaneous means not the total time, but at a certain instance within the total. Thank you. The next qualifier is average. So we have average velocity and average acceleration. And this is this. For the average velocity, it is the rate of change of displacement of a body in motion with respect to the total time taken. So when you compare the displacement of a body to the whole total time taken, that is what we refer to as average velocity. And the same goes for the average acceleration. When you compare the change of velocity of a body in motion with the total time, you have just found the average acceleration. So a quick review. The instantaneous just look at a short period of time, whereas the average look at the total period of time. The third qualifier is uniform. When you say something is uniform, it means it is constant in phases. So velocity being displacement over time. When the displacement over time is constant, we say it is uniform. That means it's defined as a body can be said to have a uniform velocity if the rate of change of the displacement of the body in motion with respect to time is constant. And for the uniform acceleration, that is changing velocity over time for acceleration. And so you can also describe a body to have a uniform acceleration on condition that the rate of change of velocity of the body in motion with respect to time is also constant. That means that as you move from an initial stage to a final stage, it is having a uniform acceleration. It is constant throughout. And we say uniform. Then lastly, non-uniform. So non-uniform typically becomes the opposite of uniform. So if uniform is constant, then non-uniform is not constant. So when the rate of change of displacement of a body with respect to time is not constant, it is called non-uniform velocity. And when the rate of change of velocity of a body in motion with respect to time is not constant, it is referred to as non-uniform acceleration. So friends, this is the end of our lesson for today. It's been full of terms, but I trust you have grasped the concept. So let's provide a summary of the whole lesson, then we'll end the lesson for today. Today, all I've said was if you divide distance traveled by time, it is equal to speed. And so speed is distance over time. And when you divide the displacement of a body with time, you get velocity. And so velocity is displacement over time taken. Then, when you look at the division of the change in velocity of a body to the time taken, it is acceleration. And so acceleration is change in velocity over time. This must be taken seriously, and you have to understand this perfectly. Lastly, we looked at deceleration, and that is also acceleration, but in a negative sense. For the qualifiers, what we said was if you have instantaneous of any of these figures, what it means is the time taken is just an instant or a short period. And so I can say instantaneous speed, which means that distance over a short period of time, instantaneous velocity, displacement over a short period of time, and so on and so forth. However, for the average, it looks at the total time taken. Then we said uniform means when the rate of change of a parameter with time is constant, that is uniform. So you can say uniform speed when distance over time is constant, uniform speed. When displacement over time is constant, uniform velocity. When the rate of change of velocity with time is constant, uniform acceleration. Then the opposite hold for non-uniform, which becomes not constant. Thank you very much for your audience. The next lesson is going to be interesting as we'll be building on what we have learned today. We will teach it very well, and based on today's understanding, it will be well explained. Thank you very much. I have been a personal tutor, Samuel Enyima. Till then, stay blessed.